Now let's take a look at another example. We're going to start with identifying the vertex for this one. So my vertex is going to be, let's see, I see a positive 2, so that's going to be a negative 2, and then a positive 5 for my y value. So at negative 2, positive 5, I'm going to plot my vertex. From there, I'm going to pick some points to the right and start plotting. So if I plug in a value, let's see, I started at negative 2. Let's plug in an x value of negative 1. If I plug in an x value of negative 1, the parentheses becomes 1. We square that, still 1, and then take the negative of it, negative 1. Negative 1 plus 5 is 4. So my next point is going to be plotted at 4. If I plug in a 0 for x, then the parentheses becomes a 2. 2 squared is 4, and we take the negative, and then finally add 5. So negative 4 plus 5 is equal to a positive 1. So that's my next point. And I think I can squeeze in a fourth point here. If I go ahead and put a 1 in for x, I get 1 plus 2 is 3. 3 squared is 9, and I take the negative of it. Negative 9 plus 5 gives me a negative 4. So at 1, I can say that I'm at negative 4. Let's go ahead and draw the axis of symmetry, and that allows me to reflect those points in order to get the rest of the curve. And negative 5, negative 4. So my graph is going to look something like this. All right, let's go ahead and identify the transformations that have occurred. The first thing I see is a negative sign, and a negative sign means that I have reflected over the x-axis. Again, it's outside of parentheses, so that is a reflection over the x-axis. The second thing that I come across is that I see I have a plus 2 on the inside. And so a positive 2 inside is going to move us to the left. So we're going to go left by 2. And then finally, at the tail end, I see a plus 5. And a plus 5 is going to move me up by 5. Finally, let's go ahead and talk domain and range. Domain is starting to sound like a broken record. It's going to go from negative infinity to infinity, just like it always does for a quadratic function. Our range, notice that our arrows are pointing down, so we're starting at negative infinity, and it goes up to a value of 5. 5 is included, that is a point on the graph. Let's look at a couple more examples now. Number 9 says f of x is equal to 2x squared. So let's go ahead and identify our vertex first. And I'm going to notice that I don't have anything in parentheses with x, and I don't have a number added or subtracted at the end. So that means that my vertex is at the origin. It's at 0, 0. The thing that is different about this one is that I have a 2 out here in front. 2 is bigger than 1, so that means that we have a vertical stretch, not a vertical shrink. I'm going to go ahead and note that as a vertical stretch by 2. And so let's see what that makes our graph look like. I know that my vertex is at 0, 0. And so now if I start plugging in some numbers to the right of that, at 1, I get 1 squared is 1, and then times 2 gives me a 2. So I'm going to plot a point at 1, 2. If I plug in a 2, I'm going to get 2 squared, which is 4, and then 4 times 2 is 8, so I'm actually a little bit above my graph at 8. So at 2, 8. And notice that my graph is kind of skinny. It is skinnied up by that factor of 2. Noticing that my axis of symmetry is the y-axis, I can go across the y-axis and plot my points on the left-hand side and finish off my graph. All right, let's talk domain and range here. So domain is always going to be all real numbers, or negative infinity to positive infinity. Range in this case has not changed from what our parent function is because it starts at 0, and so then it goes to infinity. Go ahead and pause the video here and see if you can wrap up with problem number 10 and identify the graph, the vertex, what transformations have occurred, domain, and range. Then come back here to see how you did. All right, let's check your work here. You should have gotten a vertex at 0, 1. There wasn't anything in parentheses with x to move our x value, but our y has shifted by 1. If you identify your vertex and then you can plug in a couple of more points. In this case, we're going to be running out of graph pretty soon. If I plug in a value of 1 for x, then I get 1 squared, which is 1, times 3 is 3, plus 1 is 4. But then if I plug in a value of 2 instead of x, I'm going to get 4 times 3 is 12, plus 1 is 13. We've completely run off the graph, so I'm not going to plot that point. I'm just going to identify my axis of symmetry and then plot the point on the other side. The 3 is a vertical stretch by 3 because it's out in front of the x. There's no parentheses or anything. And then the plus 1 is an up 1. Domain, as always, is negative infinity to positive infinity. My range this time has just shifted up 1, so it starts at 1 and goes to infinity.